Thanks, Subis, for the introduction, and thank Michael for inviting me to this forum. My name is Xueqiang. You can also call me Brandon. I'm an assistant professor in the Department of Computer Science and also Cybersecurity and Privacy Cluster, joining this fall. Before joining UCF, I got my Ph.D. degree from the Indiana University, and also I worked for a short time on Semantic Research Lab and also Neo USA on the smart home device security and also vehicle security. I also worked in Amazon Lab 126 on the device security automation and vulnerability management. In terms of my past research achievements, we got bug bounty rewards from Google, from Facebook, from Twitter for our findings of the vulnerabilities or the attacks that are targeting their products. And also, I co-authored 2 papers that are among the finalists of the Best Applied Security Paper Award for CISO 2018 and 2019. In total, I also have like 14 co-authored 14 top conference security papers with 2 US patents, and also I was one contributor of the over 50 different CVEs, basically the vulnerabilities related to the open source software, IoT, Android, and iOS. I also served as a reviewer and PC member for a few security-related journals and conferences. And in terms of my research, I focus on conducting experimental analysis using automated and data-driven security techniques for the purpose of identifying, understanding, and mitigating security and privacy threats in the real systems and applications. Specifically, I work on a few lines of research. For example, I work on mobile security, such as discovering attacks that are targeting the key mobile system features, and also design security enhancements for the new mobile device use cases. And also, I perform large-scale study of the vulnerable and malicious mobile applications. I also do research on IoT security. For example, I did research to design lightweight analysis tool for identifying the IoT data vulnerabilities and IoT data exposure. I also work a little bit on software supply chain security. I focus on understanding the vulnerabilities and malicious activities in the untrusted third-party code. And I also did research to understand what are the attacks that can happen on the app build tools. And in addition to that, I'm interested in cybercrime. I did research such as an empirical study on understanding the cybercriminal activities on different platforms. And a key goal of my research is to bring in more transparency, like security and privacy transparency to those platforms. So nowadays, both the users and the developers require security and privacy transparency to the devices and applications. For example, if I'm a user, I'm concerned about what kind of my personal data are collected by the smart home device and whether they are sharing it to the third party. And if I'm a developer, I'm concerned about whether the software or the libraries I'm using are affected by the known vulnerabilities. And there's already a few proposals and solutions provided to improve the transparency. For example, NIST has a white paper talking about the customers labeling program, and a team in SMU has proposed to use IoT labels. And both Apple and Google has a proposal, has enabled a feature on their App Store showing, talking about the privacy nutrition labels or the data safety of the applications. And the main idea of these approaches and the solutions is to ask the device vendors and the app developers to voluntarily specify the security and privacy labels and their practices. And there are definitely a few challenges for those proposals and solutions. For example, almost all the devices or the applications may make use of the third-party code. The developers or the owner may not know what kind of data and security practices are in the third-party code. And furthermore, many of the device vendors or the app developers may not want to cooperate or don't have the security and privacy resource to cooperate. And even worse, some of them might be malicious. And therefore, in addition for the stakeholders to voluntarily specify their security and privacy practices, I think that we need to have some new techniques in place to proactively scan or evaluate the security and privacy posture of the devices and applications. So this is beneficial for both the device vendors and regulatory agencies to check the compliance status and the threat to the devices and applications. And in the following slides, I will use 2 examples to demonstrate my past effort on those directions. So the first effort I want to talk about is evaluating IoT device security through mobile companion apps. It is essential for us to evaluate whether the IoT devices are affected by known vulnerabilities in order to reduce the chance of exploitation. And for this purpose, previous research has analyzed the device firmware, the device traffic, and also the physical device. And one prominent challenge of those previous research is that they cannot detect the vulnerable devices at scale because for the researchers, they may not be able to get a large number of devices and set up them for testing because it is not only expensive but only tedious to set up for testing. And in our study, we actually have 2 insights that help us to efficiently identify some of the vulnerable IoT devices. The first insight is that many of the device vendors will build their device by combining the modules from the upstream vendors. Therefore, if there is a vulnerability in the upstream modules, there is a likelihood that multiple IoT devices will be affected. The other key insight I had is that many of the IoT devices are just headless. In order to talk to those devices, the user needs to rely on some mobile apps. We call them mobile companion apps. And also, those mobile companion apps are usually a very good estimation of the IoT device. Combining those 2 insights allows us to design a platform that can help us to efficiently identify the vulnerable devices that are affected by the same vulnerable upstream modules. And instead of analyzing the devices directly, we can actually get the device information by analyzing the mobile companion applications and those information to infer whether the devices are affected by a common vulnerable component. And this kind of process would not require physical access to the device and also their firmware, and thus can scale better. And in the right side, I will show just show a framework of our approach. So basically, we collected a large number of apps. We gathered the device information by analyzing the app, and then we cluster the devices into different families. Upon getting those families, we will use the existing known vulnerability report and see if the indicator of the vulnerabilities are mentioned in the device family. So therefore, we can detect families of potential vulnerable devices. And using this approach, we were able to evaluate over 2,000 applications that cover over 1,000 device vendors. So this scale will never be met by the previous studies. And further, we were able to get over 100 device families that make use of the same software, hardware, or protocol, or cloud backends. We further made use of these device families to check if they are affected by the known vulnerability. In the research, we made use of 4 known vulnerabilities and was able to identify over 300 potentially vulnerable devices. We further reached out to the device vendor and also get a few devices and verified half of the devices, and found that our approach was able to identify the vulnerable devices with a pretty high accuracy. And we further released our app set, which helped the researchers from a few universities to conduct IoT security research. For example, the researchers from the UC Santa Barbara, Ohio State, and Nankai University. And also, we did a few follow-ups. For example, we, in collaboration with the research labs, we filed 2 patents on the smart home device security. And also, in my own team, I had a follow-up to demonstrate we can actually use the mobile companion apps to evaluate the IoT data exposure. So, in the second work, I want to talk about the security risks of third-party libraries in mobile supply chains. The third-party libraries and dependencies can introduce security risk to app supply chains. And a previous study already showed that third-party libraries are in the same process or the sandbox as a hosting app. Therefore, they can abuse the capabilities of the hosting app or steal data from the hosting app directly. But it's not known to us whether the malicious third-party library could steal user private data when those library to hosting app channel is closed. In this study, we actually found a new type of attack, which we call cross-library data harvesting attack. As the picture shows, we got, as the picture shows, if a malicious library, which is a one audience, was in the same process as the victim library, which is the Facebook library, the malicious library will be able to collect the data from this victim library, like the tokens, and then use the token to get all the user profile and activity data, and then send back to the malicious server. And we found that this behavior is not only unethical, but also illegal. Therefore, we reported the behavior to the Facebook, and Facebook sues the one audience company in order to stop them from stealing data from Facebook. And we further want to evaluate whether this behavior, these malicious libraries are prevalent in the wild. Therefore, we designed an approach using code analysis and also natural language processing-based analysis on the term of use. And using this approach, we were able to analyze over 1 million applications, were able to find over 40 different libraries that stealthily harvest the data from the popular SDKs, including the Google Ads, Facebook, Twitter, WeChat, and LinkedIn. And we reported all those findings to the companies, and they took them seriously. And some of the companies, like Facebook, Google, and Twitter, awarded us with their bug bounty program. And for the future work, I found that my research focused on the third-party dependencies or the libraries or the upstream modules. And this only represents a small part of the supply chain. And therefore, I want to understand what are the difficulties of the security and privacy transparency that are introduced by the other stakeholders in the supply chain. And furthermore, I want to understand, I want to extend my research to two directions. The first direction is that we are always talking about the transparency to the users and developers. Therefore, we need to understand the user or the developer's perception towards the transparency measures, such as security and privacy labels. I also want to have a better interpretation of the security and privacy related laws, especially when they are related to different regions or different ethnic groups of the users. And in the end, I want to thank all my collaborators from universities, institutions, industry, and also research labs. And I guess I'm ready to take a few questions.